All right, let's look at some practice problems. Number 1, CGHJ. So our big square is the image, CDEF is the pre-image. So which one is the first picture that was drawn? Okay, pre-image is our starting figure. So pre-image is what we started with. The image is what we finish with. Okay, the question says, what is the scale factor of CGHI to CDEF? So if we go back and think about similar figures, when we're looking at scale factor, we really just need to relate one side to the matching side in the other figure. So let's start out with CGHI, big square. What's the length of one side? Well, if you just count it out, we've got 8 units. What about the length of one of the smaller ones? So we're looking for scale factor of CGHI to CDEF. So look at the corresponding side. Again, HI and EF. Excuse me, that should be a J, not an I. So those match up. Those are my corresponding sides. My length of EF is 4. So my scale factor, I got an 8 from the original, 4 from the first one listed, 4 from the second one listed, and then we just need to reduce that down. What's our common factor between 8 and 4? 2. So our scale factor is just 2 to 1. And that square does look twice as big. The lengths are twice as long as the lengths of the small square. Alrighty, reflection practice. So we're going to reflect the triangle that they describe with the points A, B, and C, reflect over the line y equals x. So don't forget your line y equals, negative x goes up and to the left, but we had a rule for that. Right, so we can think about this, point by point, but if we go back and think about our rule, when we reflected over the line y equals x, we flip our order and we change the signs. So the new points are going to look like negative y, negative x. Alrighty, so original A is negative 1, 4. So new A prime, flip flop, and we're going to change the sign of both of them. So 4 becomes negative, 1 becomes positive. Alrighty, point B. Again, flip flop and change your signs. So we have a positive 2 and a negative 4. New C, flip flop your numbers and flip flop your signs. So positive 3, 0 doesn't really matter on the signs. Positive or negative 0 is still just 0. So let's graph the 2 and see what it looks like. Okay, original I'm going to do in blue. So we had a negative 1, 4 as our A, 4, negative 2 as our B, and 0, negative 3 as our C. So when I do my new reflection, that means I'm going to have kind of another one of these butterfly figures. Okay, I'm going to do this one in green. So A prime is negative 4, 1. B prime is 2, negative 4. And C is at 3, 0. Connect the dots. And there we go. We've got our butterfly figure where everything is perfectly reflected over the line y equals negative x. Okay, number 3 is a translation problem. And so they're, instead of describing the transform or translation, they're just giving us a rule. So if we know each coordinate, we just apply the rule, which looks like add 3 to the x's and add 1 to the y's. So point R, coordinates are negative 1, negative 1. S is 0, 2. Q is at 3, 1. U is at 2, negative 2. So we just need to apply this rule. So new R, add 3 to the x, that'll give us a 2. And I'm just going to go ahead and do all the x's at one go, so I'm not flipping back and forth between all my rules. Okay, add 3 to our S, 0, just 3. 3 to 3 on the Q gives us 6, and 2 plus 3 on the U gives us 5. Now on your Y's, add a 1. So for R prime, we get a 0. For S prime, we get a 3. For Q prime, we get 2. And for U prime, we get -1. So now let's graph out the points and see what it looks like. So it should look like we just shifted the square over. R prime is now at 2, 0, R prime. S prime is at 3, 3, S prime. Q prime is at 6, 2, Q prime. And U prime is at 5, -1. Connect the dots. Yep, all we did was shift that square over. Okay, last example is going to do a bunch of different dilations on the same shape so we can see how they compare to each other. So the figure is triangle JKP. We're going to do 4 dilations on here. Now, if you want to try these on your own, go ahead, pause the video, try it, and then start it back up to check. Alrighty, so I probably want to look at the size or the values of each one of my coordinates. So let's see, that's going to take a long while for all 4 sets of coordinates. So let's just go ahead and keep in mind we're going either closer in or further out away from the origin. Okay, so dilation A, let's do in blue. If we go by a factor of 2, we want to go twice as far away out from the origin. So if our points are 2, 4, times 2 would be 4, 8. There's J prime. Okay, P is at 4, 2. So that means new P will be at 8, 4. K is at 6, 4. So we need to go 12, 8. Technically multiplying all of my X and Y coordinates by 2, and it does stretch it out from the origin. Okay, let's look at B. Original shape, but now we're going to factor or dilate by a factor of 1/2, which means multiplying everything by 1/2 or dividing by 2. So it's going to be closer into the origin. So let's see, J was at 2, 4, so half of that is 1, 2. So that's J double prime. P was at 4, 2, half of those, 2, 1. K was at 6, 4, so half of that is 3, 2. And again, my triangle looks half as big, but it did shrink in towards the origin. Okay, next one, let's look at C. Dilate by a factor of -1. So if I'm just multiplying by -1 on everything, I'm just changing the signs on every single coordinate that we have from our original triangle JKP. So that means if I went over 2 and up 4 for J, I need to go left 2 and down 4 for J prime. Okay. K was 6, 4. So -6, -4. Okay. This is actually triple prime because it's the third one we're doing. P was at 4, 2. So -4, -2. P triple prime. And looks like we just rotated it around, which is exactly what dilating by a negative factor does. It does reflect it over the origin. So then last one, I need a new color. Let's change this over to, let's go with a lighter purple. Why not? So D is going to be lighter purple. We're going to take, again, original, but multiplying everything by a factor of -2. So 4, 2 means -8, -4. That is our new P quadruple prime, 4 apostrophes. Okay, J, 2, 4. So -4, -8. Count carefully. There's my new J quadruple prime. K was 6, 4. So times -2, negative 12. So 2, 4, 6, 8, 10, 12. 4 goes to negative 8. So 2, 4, 6, 8. K quadruple prime, connect your dots. Again, twist it around and upside down and twice as big as our original figure. Alrighty, it's a lot to do in one lesson, so I want you to do your practice today, and then we do have a quiz on this, but no new lessons. So we're going to spend the first half of next class working on a quiz practice. But if you do finish your practice early today, go ahead and get a head start on it. And then our quiz will be the second half of class next lesson. Let me know if you have any questions.